In this video, we are going to take a look at an example where we are going to try to determine the concavity of a function. And the function that we are going to look at is going to involve some trig functions. In our previous video, we looked at our two examples above here that I've crossed out. You can look back at our last video and see those. But let's look at this function, g of x equals 2x minus tangent of x. We're only interested in finding the concavity in the interval from negative pi over 2 to positive pi over 2. So outside of that, we are not going to worry about the concavity. We only want to know in that interval. So first I would observe, is there anywhere that this function is undefined in this interval? And so tangent of x, it is undefined in a lot of spots. It is undefined at every single odd multiple of pi over 2. But negative pi over 2 and positive pi over 2, those are the only two odd multiples of pi over 2 that occur in this interval. So there's not anywhere else where this function is undefined. So then next we want to take our first derivative and then take our second derivative. Our first derivative is 2 minus the derivative of tangent is secant squared x. And our second derivative is negative 2 secant x times the derivative of secant x is secant x tangent x. So this is negative 2 secant squared x times tangent x. What are we going to do with that second derivative? Well, with that second derivative, we want to find out where does it not exist on our interval and where is it equal to 0. And so our second derivative is equal to 0 would tell us that either secant squared is 0 or tangent is 0. Secant squared, that is never going to be 0. It has a graph that the range of that graph goes from negative infinity to negative 1, and then from positive 1 to infinity, but it never gets anywhere between negative 1 and 1. For tangent, this is going to be 0 when x is 0. In fact, when x is any multiple of pi, but 0 is the only one in this interval that we are interested in. We should also think about where is that second derivative, where does it fail to exist? And when we think about the second derivative here, it's going to fail to exist anywhere that cosine would be 0. But those are only those multiples, odd multiples of pi over 2. And so that doesn't happen anywhere in our interval. All right, so again, our interval is only going from negative pi over 2 to positive pi over 2. And so now we'll do a sign chart for that second derivative. We're going to go from negative, not infinity, negative pi over 2 to 0. And then we'll go from 0 to positive pi over 2. Those are the only places we're interested in. Right, we're restricting ourselves to this interval. So we want to pick something between negative pi over 2 and 0. I would plug in negative pi over 4. If you plug in negative pi over 4, we're plugging that into the second derivative. So we're plugging that in here. Whenever we take the secant stuff and square it, that will be positive. Tangent of negative pi over 4 is negative. But then multiply that by that negative out front, and we're going to get a positive here. if we plug in positive pi over 4, we will get a negative as an output for our second derivative. So g is concave up on the interval from negative pi over 2 to 0, and it is concave down on 0 to pi over 2. That is how we can find our intervals of concavity. In our next video, we are going to look to see how we can use the second derivative to not identify intervals of concavity, but see if we can use it to identify a maximum or a minimum value, a relative maximum or relative minimum value. So we will look at that next time. We will see you there.